This is lesson 8 today, and as usual, we're going to start by going to the GitHub page for the course. It's this one here. And go down and click on Lessons, and we're lesson 8 today. So this one is a little different in that instead of using, so this is what you're seeing is an Ipython notebook or a Jupyter notebook. Same thing basically. And so what you're seeing is an Ipython notebook, but it's all markdown format. You can see there's no cells of code. The code is just written, copied and pasted into the markdown file. And so the reason is that for today's lesson we're going to use the Ipython interpreter or the command line version of Ipython. So when we have Ipython and notebooks as part of our toolkit, we have actually at least 3 different ways we can use, well, actually more. So we have the Python command that's on our computer. We can just type Python and we can have an interactive prompt where we can write code and see output. And then we can use that same program to run a script. So we can type Python and the name of the script, and then maybe even some arguments, and that will run the script, which is in a text file. But there's another command called Ipython, which you wouldn't run a script that way, but you can open up an interactive terminal session. And that's going to be analogous to what's running in your notebook, except with the notebook you're getting this graphical user interface and the ability to click and copy and paste and do all this stuff that we've been doing. But you can do a lot of the same stuff with just the Ipython interpreter. So that's what we're going to do today. And some people find that this is a better way to handle certain tasks and to debug and to do more interactive things, and just a different experience that you might enjoy. So what I'm going to do is bring my window over to the side here. We don't need to copy and paste the lesson today. I'm just going to put my notebook here. I'll make it a little smaller. And then open up a terminal. And I'll make it so we can see both windows at the same time. And then we're going to do the typical command where we type source activate Python 3. And so we'll see we're now in our Python 3 environment. And finally, we type which Python, and that's where our Python is. And if we type which Ipython, in that same folder we have the Ipython command. So we can type Ipython by itself, and it will bring up this prompt. The Python prompt has three little greater than symbols. The Ipython prompt has this in and out prompt. The in prompt is the prompt, and it has a number corresponding to the line number, just like your notebook does, which comes in handy, as we'll see. Yeah, so there are a number of advantages of using Ipython versus Python, which we'll cover today. But there's all kinds of special commands. You can actually, for an example, you can run shell commands from the Ipython, which you can't do from Python, and all kinds of other things. If you're doing an interactive Python session, I highly recommend you use Ipython. In fact, that's actually how this whole thing got started. Fernando Perez wrote the Ipython software as a interactive Python, better interactive Python environment, and then after that, then made the notebook thing on top of that, and then the notebooks became so popular that they expanded to other programming languages like R and Ruby and Julia and all those things. So, okay, so what we're going to do in the code realm today is review some of the things we've done. This will be now the third time that we've covered a lot of these topics, but I think the repetition will be good, and we'll see a few new features, and you'll experience it in a different interface. So I think it'll be helpful for you. Okay, so a lot of this lesson from today is from the Python documentation. And that's linked here if you want to go and learn more about it. This one is actually linked to the Python 2 version, so I'll have to update that link. But the basic functionality is almost identical. So we've covered a few of these a couple lessons ago, but with lists we have the ability to append an item to the end. We can extend the list by appending all the items in the list. So that would be like append, but with more than one item. We can insert in the middle of a list an item. We can remove an item based on the value. We can pop off an item from the list. By default, it just removes the last item, or you can specify the index that will be removed, the item corresponding to the index that would be removed. You can get the index of an item based on, you look up the value and get the index to come back. You can count the number of times a given thing appears in the list, and you can sort the lists using some different parameters. And you can also reverse the elements in a list, as we saw before. So what we're going to do is test out some of these features using the Ipython environment. And so I think the easiest thing is to copy and paste. So you have to be a little careful, but if you have this window open, you can just put your cursor over the text, highlight it, and then if you're on a Mac, it's Command-C to copy, and then you can go over here to Ipython and type Command-V, and you'll see that it gives you some coloration based on the values, and it highlights these brackets so you can see where the brackets start and stop. It has some nice features that come in handy. So we've now entered this list that has some integers and some floats. And now we're going to copy this item. And so what this is doing is it's going to print the values of the list A and counting the number of times that 333 is in the list, 66.25 is in the list, and then the string X. So we can see that the first one is found twice, the second one is found once, and the third thing is found 0 times. We can then let's try, just for fun, we can try to type it. Insert, and yep. If you get a syntax error, you probably didn't type exactly what I typed. Oh, weird. Mine puts a little dot going down to it. You might have not copied it exactly from here if you're getting a syntax error. So we're going to insert at position 2, -1. So so position 2 is the third element of that list. So at position 2, we're going to insert -1. So you can see that's what happened here. There's our -1. We can also do a.append, and then we can type a again, and we can see we've appended this item to the list. Okay. We can do a.remove. You notice Ipython supports tab completion, so I can type rem, and so it knows that a is a list. In fact, if I go back and just type a dot and hit tab, it's going to give me all these options. So a list has these 11 methods that are specific for lists, and so Ipython knows that a is a list, and so when we type a dot, it gives us all these options. So it's very handy to see what options you have. If maybe there's things you didn't realize you could do. Also, it gives you tab completion. So you're like, I don't remember if it was called extend or something else. So I'm gonna tab complete and see what it does. So, but if I want to remove, I can start typing rem and then tab, and it will finish the rest. This is really handy. You should be using this as much as possible. Question? Yeah.
When you do the index, if you have a repeated element, it won't give you both indexes, right? It will just give you the first one that comes.
I believe that's correct. We can look. So one thing we can do is there are ways. There's workarounds. I don't know exactly. It seems like with index, it doesn't give you multiple things. But in practice, once we start using pandas, like there's a lot of other ways. If you're dealing with a data frame or something, this is dealing more with the core functionality of lists.
Right.
And
yeah, I've seen it where you would do a loop for some high level.
yeah. Yeah, I mean there's definitely a way you could do it in one line. If you could imagine, you could imagine like some sort of list comprehension where you got the index and then like remove that item and then you got the index again and then something like then you'd be yeah. The real way that you would do it in like say in pandas would be you had a column and you wanted to find all of the indexes that corresponded to a certain value. You would say this column equals that value, and it would either give you true or false, right? And then you would say what are the indexes of those true false values, and it would spit that out. And the nice thing about that is that then you could then use those indexes to get all the rows, say, that corresponded. So let's say you wanted all the rows that had a certain value in one column. That's a really common thing to do. So pandas gives you a way to do that. You have a table and you say what are all the rows that have 5 in column 3, and so you can say. Yep, exactly. So that's really powerful, and we'll see that. What I want to get out of this is give you a little more familiarity with lists and things you can do. But in practice, you won't use this as much once you start using some of the more advanced packages like Pandas specifically. But this is all underlying, including the Numpy Arrays, which we'll see. Numpy is another package that's somewhere between this core functionality and Pandas. Numpy is kind of in the middle. It's more for handling numerical data, and you have these things called arrays, which are similar to lists, but they're a lot more powerful. But it's all based on this sort of core functionality. So it's good to have a handle on this, and also to familiarize yourself with the Ipython environment. So let's we removed 333 from the list. So now but it just removed the first instance and not the others. We can reverse the list, which is done in place, so it changes the value of A. We can sort the list, so now it's sorted numerically. And we can do this pop command where we pop off the last value, which returns that value, and then A is this. So we could have done, say, x equals A dot pop, and that would have given x the value of the thing that was removed, and then A would have been, the same thing would have happened to A, but we'd now have stored the value that we popped off. Okay.